In chemistry, the letter H represents the enthalpy of the system. Enthalpy refers to the sum of the internal energy of a system plus the product of the system's pressure and volume. The delta symbol is used to represent change. Therefore, delta H represents the change in enthalpy of a system in a reaction. Assuming a constant pressure, a change in enthalpy describes the system's change in heat. Scientists can't actually measure the system's enthalpy, but they can measure changes in enthalpy. There are four methods for finding the delta H. The first is calculated to use average bound enthalpies. The second is measured to use a calorimeter. The third is calculated to use Hen's law. And the fourth is calculated using enthalpies of formation. Calorimetry is the measurement of heat transfer, and calorimeter is the device used to determine the amount of heat transferred. And the specific heat capacity is the amount of heat required to raise the temperature of 1 gram of a substance by 1 Celsius. So now let's look at the question. It asks us the calculation of the amount of heat needed to purify 1 mole of aluminum originally at 298 calcium by melting it. So from here we're able to know that the M is actually 1 because it already told us. And let's go to the second sentence. It says the melting point of aluminum is 933 calcium. That is actually the final temperature of the melting Al. So by getting know the initial temperature and the final temperature, we are able to know the temperature change, which is the delta T in the formula. And last, the molar heat capacity of aluminum is 24 joules per mole times calcium. So we are able to know that the C right here is actually 24. And now let's put all this number into that formula, which is Q equal to 24 times 1 times 933 minus 298. And what we will get is 15 kilojoules. We got to notice that the question asks us to calculate the amount of heat, and it also says the heat of fusion of this is 10.7. So we need to add this the energy of fusion to the energy required to melting. Together is the energy that required for purifying, which is 10.7 plus 15 equal to 26 kilojoules. After getting the answer for the A part, let's go to the B part. So it asks us which one requires less energy between recycling existing aluminum or extracting aluminum from aluminum oxide. From the formula it gives us, we can get to know that there is 2 aluminum as a product in the reaction. So, and we also know that the enthalpy change of the overall equation is 1675 kilojoules per mole. So, and there is also 2 more. So let's do calculation to get the enthalpy change of 1 mole of aluminum, which is 1675 times 1 over 2. That will equal to 837.5 kilojoules per mole of aluminum. So when we compare these two numbers, we can obviously know that the energy that required for extracting is over 800, but the energy that used for recycling is just 26. So we can know that recycling definitely requires less energy. So let's go over the question again. For the A part, we actually is using the calorimetry method of finding the delta H. And for the B part, we are actually using the Hen's law to calculate it. We got to know that in the first question, it is Q. That is the heat lost or gain in the experiment that took place in calorimeter. And in the B part it is the delta H because that's the heat lost or gained in a balanced chemical equation. Remember when we use the delta H to calculate the energy that used for extracting aluminum, because if a reaction is carried out in a series of steps, the overall change in enthalpy will be equal to the sum of the enthalpy changes for the individual steps. So here is all for today's explanation of the FRQ questions. Thank you.